we are going to apply what we learned a couple of sections ago, and we are going to rewrite expressions using radicals, and we're going to, you can't see a thing, we're going to rewrite expressions using radicals, and we are going to use rational exponents, which if you remember from a couple sections ago, that means that we are going to have fractions or ratios in our exponents. So we're going to practice, all we're going to do is go back and forth a few times. The challenge is going to be reducing something if it's not a perfect power. Okay, so we're going to practice on our calculator, but we're also going to practice bouncing back and forth in the notation. So I'm going to start off by doing the cubed root of 343. So the first thing I want to practice is using an exponent. So remember, 343 can be written to the first power. So that's just implied. So what I'm going to do from here is say, well, I've got 343 to the first power, but I'm taking a cubed or a third root. So rewriting this radical expression using rational exponents means I've got 343 to the 1/3 power. So this is another cool thing. If you remember a couple sections ago, we were using our calculator and we were having to use this power button right here. And so like I would have to say the cubed root and then go and find that key right there. So there's my cubed root of 343, and that gives me 7. So I already know this simplifies down to 7. But it also makes it easier. Now pause for a second. What does that mean? That means 7 times 7 times 7, or 7 times itself 3 times, is 343. So what I could have done was taken 343 raised to the, and then in parentheses, I could have done the 1/3 power. So it's going to take 343 to the first, and then take a cubed root, and it's going to give me 7. So that's just one of those tricks. Sometimes it's easier to use a rational exponent than it is to use the buttons on the calculator. So let's try another one. We have the square root of 3 to the 4th. So I want to write this using rational exponents. So first of all, what's implied? My index is implied to be 2. So that means I've actually got a 3 to the 4th power, but I'm taking a square root. Well, this is just a fraction. He's up in the exponent, but he's a fraction, which means 4 over 2 reduces to 3 squared. I happen to know what 3 squared is. 3 squared is 9. Okay, 3 squared is 9. So, more practice. I have the square root of x to the 8th. So I'm not going to be able to get a numerical answer on this one because I'm starting off with variables. But remember again, your index is 2. So how am I going to rewrite this using a rational exponent? I've got an x to the 8th, but I'm taking a square root. Well, 8 over 2 reduces to a 4th power. And that's as far as I can go. So that simplifies to an x to the 4th. Now that should make sense because the square root of x to the 8th, what did I multiply by itself to get x to the 8th? X to the 4th times x to the 4th is x to the 8th. All right, I have a 6th root of n to the 5th, and I just want to write in exponential form using rational exponents. So again, I am not going to get an answer, but I do have an n to the 5th power. Well, now that I've got a 5th power, what root am I taking? I'm taking a 6th root. So this whole thing right here is an exponent. Sorry, my dog just scared me to death. All right, so I've got an n to the 5th power, but I'm taking a 6th root. So that 5/6 is in the exponent. All right, I have a cubed root of 729, and I want to write that using exponents. I want to write this using rational exponents. So what do I know first? That is a degree of 1, or an exponent of 1. So I can rewrite 729 to the first power, but I am taking a cubed root. And when you put that in your calculator, I can either say the third root of 729 will be 9, or I can say 729 raised to the, and then 1/3 power in parentheses. Otherwise, that's going to take 729 to the first and divide that entire answer by 3, which is not what you want. So that gives me 9. I got the same answer. Okay, so this is it using rational exponents or an exponential notation, and then that simplifies down to a 9. So I have a 4th root of 16. Okay, so practice putting that in a rational exponent. So I've got a 16 to the first power that's implied. So 16 to the first, but I'm taking a 4th root. So what times itself 4 times is 16. 16 goes down to 4 and 4, which goes down to 2 and 2, 2 and 2. So I know my answer is going to be 2, because 2 times 2 times 2 times 2 is 16. So I'm going to take a 4th root of 16. That's using radical, and I get a 2. Or I can say 16 raised to the parentheses 1/4 power gives me 2. Okay, so either way, I got the same answer of 2. All right, I have an 8th root of -1. So the first thing I'm going to do is what power is applied to my -1. Be careful, because that power applies to the entire -1. So I'm going to rewrite that as -1 raised to the first power, but I'm taking an 8th root. Okay, -1. So I need parentheses this time, because that root, that 8th root, belongs to the -1 as well. It belongs to the negative. So in my calculator, I'm either going to do the 8th root of -1, use a negative, not a minus. And when I hit enter, it says, wait a minute, you've done something wrong. Okay, so let's try it the other way. I have -1 in parentheses, because I want the exponent to apply to the whole thing, raised to the 1/8 power, and I get an error. Okay, so what's the issue? Well, remember, negatives under even roots will take you to imaginary number land. So a negative under an even root will take you to imaginary number land. So what you have is this is not real. That's going to be a not real answer. All right, I've got 4 raised to the 1/2 power. So now we're going to go backwards. I've got 4 to the first power. But what root are you taking? You're taking a square root. So that really means the square root of 4. So it's understood that that's to the first power. And it's understood that you're taking a square root. So I'm too lazy to write the 1. I'm too lazy to write the index. Well, do I happen to know what the square root of 4 is? I do. It is 2. So I've taken my expression that's using rational exponents, and I've changed it into radical notation. And then I simplified it if I could. Okay, so I've got a 49 over an 81 raised to the 1/2 power. So that 1/2 belongs to everything on the inside. 49 over 81 doesn't reduce, but I do know that this is a 49 over 81 to the first, and I'm taking a square root. So the question is, remember that can go to both of these. So what's the square root of 49? What's the square root of 81? So that radical can go to both the numerator and the denominator. All right, I have a negative 1024 to the 1/5 power. So the first thing I want to do is I want to take that and change it into radical notation. So I've got a negative 1024 raised to the first, but I'm taking a 5th root. So I have the 5th root of a negative 1024. So hopefully some alarm bells are going off in your head. Am I allowed to have a negative under an odd root? Yes, I am. Okay, it's okay. So let's see if this ends up something pretty, and then we'll go from there. So I can either enter it using rational exponents, or I can enter it using a radical. So I'm going to go ahead and do a radical since we're supposed to be practicing back and forth. So I'm going to take a fifth root of negative, not minus, 1024 and hit enter, and I get a negative 4. Okay, so that ends up being, what does that mean? That means that negative 4 times negative 4 times negative 4 times negative 4 times negative 4 is negative 1024. All right, more, I have 256 raised to the 1/4 power. So the first thing I'm going to do is change it back into radicals. So that means I've got 256 to the first power, which is fine, but I'm taking a 4th root. So I want the 4th root of 256. So the 4th root of 256 should be 4, if I'm awake enough. Wait a minute, where'd it go? That one. 256 gives me 4. Look at that, because 4 times 4 times 4 times 4 is 256. So my answer on this one is 4. All right, I've got m to the 3/4. So we're just going to practice. Let's write this in radical form. So really and truly, that's m to the 3rd power. But you are taking a 4th root. Okay, so that's your answer. That's as far as you can go. Okay, remember that 4 is tiny. It's a little index. That 5 is tiny. It's a little index. All right, I've got 16 to the 3/2 power. So these ones are going to be a little bit more exciting. And I'm just going to tell you, I'm going to finish this video. I try and keep it to 15 minutes, but we're just going to knock this one out. All right, so I've got 16 to the 3/2 power. Now you have to look at this one of two ways. Okay, do you agree that 3/1 times 1/2 is 3/2? Yes, it is. Okay. Do you agree that 1/2 times 3/1 is 3/2? Yes, it is. So I want to show you a trick. You can still do these you can still do these as in your calculator, but I want to show you a trick that we do. So remember that a power to a power we would multiply. So I can break this thing down is what I can do. I can do a decomposition on my exponent. So what I could do is 16 to the 1/2 power and then cube it. Okay, because a 1/2 to a 3rd would give me 3/2. So I can take the root first is what I'm trying to tell you. And that's a whole lot easier than doing 16 times 16 times 16 and then taking a square root. Okay, so what if I do the square root first and then cube it? So what I have is the square root of 16, and I'm going to cube it. Okay, so remember this is 16 to the 1st, but I'm taking a square root. So that ends up being, well, what's the square root of 16? It's 4. What is 4 cubed? That gives me an answer of 64. Okay, so your calculator, you can still do 16 raised to the parentheses 3/2 power, and that gives you 64. Okay, but it's a math trick. We want to avoid grabbing our calculator as much as possible just because we're lazy, and sometimes we have to look for it. And so if I know little tricks like this, it's just going to make life easier. Okay, so let's try another one. We have a -8 to the 2/3 power. So -8 to the 2/3 power. So if I do the root first, it's going to help me figure out what my answer is. So I'm going to do a -8 to the 1/3 power, but then I'm going to square it. Okay, so separate the root from the power. So what is the cubed root of -8? Oops, sorry, that's a 2. The cubed root of -8 is going to be -2. Because -2 times -2 times -2 is -8. So that gives me -2. And then square that. -2 times itself is 4. So my answer is 4. On your calculator, do a -8 in parentheses raised to the 2/3 power in parentheses. And you're going to get, okay, so wait a minute, what just happened? Sometimes the calculator doesn't like this, okay? So sometimes you do have to do it a step at a time. It just hit me that this happened last semester, and we were like, what is going on? We have confused the calculator, okay? So we do need to do this one a step at a time. So what I can do is -8 raised to the 1/3 power, and I get -2. Then I need to square -2. Now be careful, because if I just square this, I think it's, okay, it will. I didn't know if it was going to leave the negative out front or if it would square it too. So I got my answer there. So sometimes your calculator is like, you know, I'm tired and I don't want to do that, which is another reason you cannot depend on technology 100% of the time, because sometimes you are smarter than your calculator. In fact, most of the time you are smarter than your calculator. All right, so I've got a -64 over 27, and I'm raising this to the 1/3 power. So what does that mean? I'm taking a cubed root of -64 over 27. A cubed root. So here's what I know. I know that -64 has a cubed root of -4, because -4 times -4 times -4 is -64. So I know that part, okay? So that numerator is -4. The cubed root of 27 is 3, because 3 times 3 times 3 is 27. So in my calculator, what I can do is -64 divided by 27 in parentheses, and I'm going to raise that to the 1/3 power in parentheses. But remember, I want a fractional answer, so I'm going to hit second and then fraction decimal, and then hit enter, and it's going to think, and it's going to give me a -1 1/3, which when I change that from a -1 1/3, that means the negative is going to come along for the ride. 3 times 1 is 3, plus 1 is 4 over that 3. Okay. So we got 2 more to do. I've got a 343 to the 2/3. Okay, so what I can do, this is just a little math trick, is I can do 343 to the 1/3 and then square it, which means I'm taking a cubed root. I discovered several problems ago that that becomes a 7, and then I can square it, which means I should get 49 for an answer. Okay, so what do I have? I have 343, and I'm going to take that raised to the parentheses 2/3 power. 2/3 power gives me 49. Okay, I just want you to see what's going on in the background. And then I've got a 121 to the 3/2 power. So 121 to the 3/2 power is going to be 11 to the 3rd, which is 331. I should get 331. No, 1331 is what I should get, theoretically. Sometimes I like to test myself, too. So I get 121 raised to the parentheses 3/2 power. So I get 1331. All right, so what I did was the square root of 121 is 11, and then 11 to the 3rd power is 1331. And that is it. You are now ready for the next part.